So for this question number 4, again, we want to know the current that is running through R1 at time equals 0. So to do this, it's kind of like our problem that we did in question 1, except we have this other resistor that got added to the mix. So to do this, the current's not going to choose a path of least resistance and only go in one way. It's going to go through, the current's going to go through here, and it's going to go through here. So it's going to go through all these resistors. So what we're going to have to do, we're going to have to get our R equivalents and find the current that's going through R1, because currents are equal to each other in series. So all we have to do, get the R equivalents. So to do this, R2 and R3 are added in series. So R2 plus R3 is equal to, and then 143 ohms. Because we know 77 and 66 equals that. And then now, because R2, R3 is going to be parallel to R5. So these will have to be added inversely. So 1 over R5 plus 1 over R2, 3 is equal to 1 over R5, 2, 3, and then you have to flip it R5, 2, 3, and that will eventually equal, once you add the inverses, it'll equal to 55, I'll write it down here, 55.98 ohms. Okay, so now you know all this, we know R523, and now we can just add R1 and R4 to that, because now everything's in series. So I'll draw a little picture. There's R1, R523, R4, just add all these numbers. R1 plus R523 plus R4, and then because we'll just add up all the numbers, that should equal our R equivalents. R equivalents should equal to 234.98 ohms. That should be our equivalence resistance throughout the entire thing. So, and since currents are equal to each other in series, all we have to do is solve for the current. So V over R is equal to I. So we know we got 24 volts. 24 volts over 234.98 ohms, and that should be equal to 0.102 amps. And that's going to be the current. And that current is equal to R1, that, and that. So the current going through here is the same here, here, and here. But we want to know the current going at R1. And that will be our answer.